Hi everyone. Good afternoon. Um, Hello. So today is Friday, October 14th. So today we'll talk about 4.4, the longer functions and its graph. And today you have quiz 4. So quiz 4 covers 3.5 to 1.7. Okay. So are you able to see your quiz on the blackboard? Mhm. So also, please do your homework. And if you have questions about your homework, ask me. And so here, uh, one of you asked me this questions. So I think this question is very good. So let's go over it together. Okay. So this is from your homework 4.1, question 10. So some of the homework, some questions like are in a group, and then the Mobius will generate one question from the group. So some of you might have this question on your homework, and some of you might not. So let's all look at this together. Mhm. Okay, so in the year 1985, a house was valued at 102,000. By the year 2005, the value has appreciated to 146,000. What was the annual growth rate between 1985 and 2005? Assume that the value continued to grow by the same percentage. What was the value of the house in the year 2010? Round your answers to two decimal places. Okay, so last time we talked about the compound interest model. Do you remember that? And so, let me write it down here. So the compound interest model, if you can remember, A equals principal times 1 plus annual interest rates over n. N is the number of compoundings raised to the power n times t, right? N is the number of compoundings per year. And if we have, the problem tells us that we have compounded continuously. Then we use the formula A equals P e to the RT. So this formula is for the compound interest. And how do we get this formula? Okay, so we start with the principal P, right? So after 1 year, after 1 year, let's say R is the annual interest rate. Let's say we only compound once, okay? Then after 1 year, the amount is the principal plus the principal times the interest. For example, if you put $1,000 in your bank, and let's say we only compound once per year, then after 1 year, let's say the annual interest rate is 5%. Then $1,000 times 5% is $50. So those $50 are your interest, right, everybody? So that's why you can factor out the P. You get P times 1 plus R. If we only have number of compounding equals to 1. This is what we get after 1 year. Is that okay, everybody? Yeah, $1,000 plus $1,000 times 5% is $50. So you get $1,050 after first year, right? And how about second year? Another year, okay? So let's say A1 is after 1 year, okay? A2, second year. Well, second year, the initial amount you start with is P times 1 plus R, right? And then this is like the principal for the second year. Your account start with like $1,050. And then after 1 year, you have this amount and times R. That is your new interest for the second year. Yes, everybody? So that's why we can factor 1p times 1 plus r. Then you have 1 plus r again, right? You factor out this, then you get 1 here, and you get plus r here. So therefore, you have p times 1 plus r2 square. Therefore, so this is after first year, this is second year. Therefore, keep going. After t years, a is 1 plus r to the t. Yes. So this is the formula if the number of compounding is 1. Okay? But if the number of compounding is n per year, well that means you want to compound like n times. That's why you divide the annual interest rate by n, and then you have this guy raised to the power of nt. Is that okay, everybody? Now, come back to our problem. So, because our problem here, it didn't tell us the number of compoundings. So you just assume the number of compounding is 1. Is that okay, everybody? So that's why we use this formula on this problem. Is that clear, everybody? So it does not say the number of compounding, then we just assume it only calculated compounding 1 per year. So we use the formula. Oh, sorry, I missed the P. P is the principal. Okay, so we use this formula. Okay, and because 1985 is such a big number, so I don't want to use that for the time. So I'm going to redefine the time. So let t be the time after 1885. So that means 1985 corresponds to t equals to 0. Is that okay, everybody? 1985 is such a big number. We don't want to plug in that big number. Do you agree? Mm-hmm. Yes. So after we make this notation of the t, then you can imagine 2005 corresponds to t equals what? How many years after 1985? 20. That's why it corresponds to t equals 20. Yes, everybody? Mm-hmm. Okay, let me use a different color. Okay, so those are the formula. Okay, now because it doesn't tell us how many compoundings per year, we just assume we just compounded once per year. So we use this formula. Okay. And when we use this formula, do you see we have two parameters? One is the principal, one is the growth rate. Okay, the growth rate R. Do you want to sit in the front? Because today this projector does not work. So we can only use this tiny one. So you want to sit in the front so you can see the board better. Oh, attendance. Yes. So this is one of your homework problems. So some of you might have this homework, some of you might not. So it's good to look at this together. Okay. Yes. So this is the formula we are using, and we know at 1985 t is 0, and the amount. Okay, the amount when t equals to 0 equals 102,000. And the amount when t equals 20 is 146,000. So we can use these two informations to help us to find p and r. Okay? We have two parameters p and r. We need to figure that out. Okay, let's plug in. So we plug in t is 0 and a0 is, so now we plug this into this formula. A0 is 102,000. P, we don't know it. We want to find the P. And then 1 plus r to the t. Do you see the t is 0? Yes, we put these two numbers into this formula. A of 0 is 102,000 equals P. We don't know P. We want to find P. And then 1 plus R raised to the T. The T is 0. Is that okay, everybody? We put those two numbers into this formula. Yes, yes, right? Okay. Remember, any number to the 0 is 1. So, oh, this is 1. Therefore, P equals 102,000. Okay? Alright, continue. Plug these numbers into this formula. A of 20 is 146,000 equals P. What's P? 102,000. And then 1 plus R to the T. What's T? 20. Yes, everybody? We can use this to find the R, right? See, R is the annual growth rate. Okay, so how do we solve for R? We both sides divided by 102,000. Yeah, everybody? So both sides divided by 102,000. Then we get 146,000 over 102,000 equals 1 plus R to the 20. Yes, everybody? And oh, do you see the 1,000 cancel? Right? Do you see that? The 1,000s cancel. So how do we find 1 plus R? Because it was 20, yeah, it's equals to 146 over 102. To get rid of the 20, you both sides raise to the 1 over 20. Yeah, this is like 20 roots of that. So that's why, oh, they cancel. We get 1 plus R equals 146 over 102 to the 1 over 20. What do you get? You have a calculator? You put parentheses 146 over 102 raised to the power of 1 over 20. What do you get? 1.018. So 1.018, like that? Oh, how about more digits? Thank you. Okay, so that is 1 plus R. Therefore, R is both sides subtract 1. Yeah? So we get 0.0180934. And because the problem asks us to round your answer to 2 decimal places. But here, percentage means you move this 2 digits. So the usage is 1.81%. Because your next digit is 9, it runs up to 1. So 1.81%. Is that okay, everybody? Yes. Okay, so that is the annual growth rate between 1985 and 2005. And then the value of the house in the year 2010. Okay, so this is like part B. Okay, so 2010. It corresponds to what's your T? 25. Exactly. So we plug into that formula. A of 25 equals P. P is 102,000, right? Yes, everybody? And then times 1 plus R. 1 plus R is this number. So if you want your number to be more accurate, it's better to keep more digits. Do you agree? So let's put this whole thing here. So yeah, 1 plus r is 1.01800934 raised to the power of t. T is 25. Okay, so in your calculator, you can, instead of putting in this number, you can put answer. Do you see there is a button? It's called the answer key. It's whatever number you get from the previous line, you can put 102,000, and then answer means this guy. Okay, the previous line. Make sure your previous line is this number, and then raise to the 25. What do you get? Anyone get the answer? Uh, it should be one something, right? One. Sorry, again. 103,000. 103. Okay. The number should be bigger than that because 25 years, so it should be more than the 20 years. Yeah. So, anyone else get a different number? Please, everybody try to plug in your calculator. Yes, it's also very important to know how to use your calculator. Okay? Oh, 159694. 159,694.78. Okay, great. Yes, awesome. Right. So this answer is bigger than 148. Yes, that's good. Do you have the same answer here? Yeah. And because the problem is that round to two decimal places, that's why you keep 0.78. Is that okay, everybody? Yes. So, my suggestion, you take notes in class, and after class, you can watch the recordings to review the notes. Please make sure you understand every problem on the notes, and then you can do your homework. Okay? So, if you have questions about your homework, feel free to ask me, or you can submit your first attempt and look at the solution and try to understand it. And then you can open the second attempt to try the problem again. If you have questions, come to see me, okay? Our goal is to make sure you understand every problem we go over and every problem on your homework. And then hopefully you can do well on your quiz. And today you have a quiz, right? And also the practice exam. So make sure you understand and be able to do every type of problem on your practice exam. And then hopefully you can do well on the actual exam. Okay? Ready? Let's try our best. If you have questions, ask me. If you don't have time to come to see me, email me, or you can put your questions here. See? This question sheet, you can put your question here. Then if we have time, we can go over together in class. Okay, everybody? And by the way, yes, please try your best to get all the possible help you are able to. So besides come to me and my office hours, there are also free tutoring service in the OSS. Okay, yes, so get all the possible help you're able to. Yes. Okay, so right, and sometimes if you miss something, don't forget to watch the recording. Okay, last time we talked about the logarithm functions and the graphs, right? And then we were looking at the domain of the following functions. And the good thing is I have my stylus pen, so the math department gave me new ones. Okay, so that I don't need to use my finger again. Okay, so we call, how do we find the domain? Okay, 3 things. So domain, then you remember 3 things. First one, if you see square root of a, what do you need the a? Greater or equal to 0. If you see b over a, what do you need? A not equal to 0. If you see log, what do you need? Yeah, a has to be greater than 0. Okay, so we keep going. Part B. Do you see square roots? No. Do you see fractions? No. Do you see log? Yes. So we need the things inside the log to be positive. Okay, so things inside the log. So x minus 2, we need to be positive. So that's why we can add 2 on both sides. We get x is greater than 2. Right, everybody? Aha, so this one is easier. 2 greater than 2 on the left hand side or right hand side? Greater than 2 on the right. Oh, do we include the 2 or not? No, so we put an open circle. That's why interval notation 2, parentheses or brackets? Parentheses. And then to infinity, parentheses. So far, so good, everybody? Okay, we keep going. All right, so here, log x squared minus 4. So similar, right? We need the things inside the log to be positive. And remember, we cannot move the 4 on the other side and take square root. We cannot do that. Our goal is to factor. Yes, everybody? So we factor. How can we factor? Yeah, x plus 2 and x minus 2. And the critical points are x equals to -2 and 2. Very good. Do we put open circle or solid circle? Open. Right, everybody? Okay, look at the leading coefficient. What's the leading coefficient? 1, right? So we start with the right upper corner. Yes. So leading coefficient is 1. We start with the right upper corner. And do you see this problem is similar to this problem, right? And because 2 and -2, they both have multiplicity 1, so we cross. Yeah, anybody? We cross. Okay, we cross it. So this is plus, this is plus, this is minus. And we are looking for what? Greater than 0. So this piece and this piece. Yes. So write it down. Interval notation. Minus infinity to -2. Parentheses. Union 2 to infinity. So far, so good. That's you. Right, everybody? Okay. And then part D. Part D. We need the things inside the, by the way, LOG means space is 10. LN means space is E. Very good. Okay, so now we require the things inside the natural log to be positive. Well, you know what's absolute value look like. What's the graph? Like that, right? So, oh, it's like that. Do you see absolute value is greater or equal to 0? But we need x absolute value to be greater than 0. That means x cannot be 0. Right? So this is the same as saying x cannot be 0. Yeah, absolute value of x is greater or equal to 0. And we want it to be greater than 0, which means it cannot be 0. This is only equal to 0 when x is 0. Alright, everybody? Mm-hmm. Yeah, we need it to be greater than 0. So that's why we want to take out the point 0. So x cannot be 0. So if you want to draw a picture, you can say 0 right here. And we take it out. So therefore, the domain is minus infinity to 0, union 0 to infinity. So this is how we can write down the domain. So far, so good, everybody? Mm-hmm. Awesome. Okay, very good. Let's continue. Simplify each expression. Okay, now keep in mind that ln and exponential function. So ln of x and e to the x, they are inverse functions. Okay, keep that in mind. Well, that means e to the ln of x is x, right? E and ln cancel. And ln of e to the x is also x. Is that okay, everybody? Mm-hmm. So, oh, ln e to the 5. What's that? ln and e cancel. You get 5. That's easy, right? Oh, how about this guy? ln of e is what? 1. Oh, be careful. This is like 1 to the 5 is 1. You see the difference? Here is ln of e to the 5. This is ln of e, and then raise the power of 5. So they are different. You see, the numbers are different. Be careful. How about this guy? 3. Yeah, e and ln cancel. We get 3. And how about this one? X. How about this one? Also X. Yeah, ln and e, the inverse function, they cancel. How about this one? Yeah, 2x squared plus 1. This example is easy, right? E and ln cancel. You just get what is left. Okay. The following. Find the inverse of each function. Do you remember our steps? Okay. Our step. How to find inverse function. Y equals f of x. That's the first step. Step 2. Switch the x and the y. And step 3. Solve for the y. And then you get y is the inverse function. So these are the steps how to find inverse function. Okay, let's follow those steps. Okay, so step 1. Y equals the function. So minus ln of negative x plus 1 plus 1. By the way, can we add those two numbers together? Can we do that? Can we add this one and this one become 2? No, we cannot, because this is inside the ln. Okay, this is the ln of that number. It's not ln times that number or ln add those numbers. So that's why if this one is inside the parentheses of ln, we cannot add this one together. So be careful. Alright, so that first step set the y equals the function. Step 2, switch the x and y. So you call it x now, and then here you call it y. Is that okay, everybody? Mm-hmm. We switched the x and y. And then we want to solve for y. So we want to solve for y. First of all, let's isolate the log term, which means we want to move the 1 to the other side. Yes, everybody? So subtract 1 on both sides. So subtract 1 here, subtract 1 here. We get x minus 1 equals negative ln of minus y plus 1. Right? So here we want to isolate the log term. Okay, it's good to write down what you are doing in each step, so you can understand. Oh, when I see a different problem of similar kinds, I can follow the same steps. Right, everybody? Okay. Continue. See, we have a minus sign in front of that, so we want to get rid of the minus sign. What do we do? Multiply by -1 or divided by -1? Yeah, everybody? So we multiply by -1, we get minus x plus 1. Is that okay, everybody? And the right hand side is ln of minus y plus 1. So multiply both sides by -1. Therefore, -1 times x, -1 times -1 become +1. Minus become positive. Yes, everybody? Okay, do you see we have isolate the log term? Yeah, the isolate means the log term is on one side by itself. Okay, and all the other terms is on the other side. So after we make sure we isolate the log term, then both sides, okay, so both sides apply E. Okay, so both sides apply E. So in this case, e to the minus x plus 1 equals e to the ln minus y plus 1. Both sides raised to the power of e. Okay, everybody? Why do we do that? They cancel out. How nice. E and ln cancel out. So we get this is minus y plus 1. So far, so good? Yeah. How do you solve for y? Subtract 1. So we have negative y equals e to the negative x plus 1, subtract 1. By the way, can I cancel this one and this one? No, this is the exponent, right? We cannot cancel it. Ooh, what is y? We both sides multiply by 1, right, everybody? So we get negative e to the minus x plus 1. And negative times -1 is positive 1. Oh, nice. So finally, we say this is our inverse function. Negative e to the minus x plus 1 plus 1. So this is our inverse function. So far, so good, everybody? Yeah. So these are the steps. We first set y equal to this function. And then we switch the x and y. And then we solve for y. Okay? How do we get rid of the log? You want to isolate the log term first. And then you both sides raise to the e so that you can get rid of the log. And then you solve for y. So far, so good, everybody? Okay, keep going. Part B. So part B. Do the similar steps. We have y equals negative 2 e to the 2x plus 1. Oh, by the way, if you have like more time, it's good that you try the problems first before coming to class. Because, math, you try a lot and then you understand it by trying. But if you can try the problem before coming to class, and then during class, you can check our answer together, and then you can see, oh, did I get this right? Did I get this wrong? And then we can Okay, everybody. You know that we have a lot to cover, right? So that's why in class I'm trying to make our class more efficient, so we go over the problem. But I really wish that if we can have more class time, we can try the problems first before we go over. Yes. Lot of practice. Yes. Okay. That's step one. Step two. What? Yeah, change y and x. So this is x. Now this become y. Step 3. Solve for y. Okay. Do you see here? We have the exponential term. So we say isolate the exponential term. Okay? Isolate the exponential term. That means you want to have the exponential term by itself on one side. So what do? Divided by -2. Very good. So divided by -2, they cancel. We have negative x over 2 equals e to the 2y plus 1. Yes, everybody? Divided both sides by -2. Yeah? How do we get rid of the e? Apply ln on both sides. Yes, everybody? Because e and ln, they are inverse functions. To get rid of the e, apply ln. To get rid of the ln, apply the e, right? So ln of negative x over 2 equals ln e to the 2y plus 1. What happened? ln e, cancel. We get 2y plus 1. So far, so good, everybody? What do we do next? Subtract 1 on both sides. So subtract 1, we get ln of negative x over 2. Subtract 1 equals 2y. By the way, the location of the parentheses is very important. So this parenthesis right here. Don't put the parenthesis here because it will be wrong. Okay, so be careful the parentheses stay here. Don't put it here. What do we do next? Divided by 2, exactly. So y equals ln of negative x over 2 minus 1 divided by 2. Yes, everybody? Right? Divided both sides by 2. Divided both sides by 2. So far, so good? Yes, so this is the f inverse of x. All right. Good. So this is how to find inverse functions. Any questions about this problem? Are we all good? Yeah? Okay. Bless you. Okay. All right. Now, let's make the problem harder. Okay? So because your exam problem will be harder. So let's change this problem to -2 ln of negative x plus 3 minus 4. So don't do the old one. Don't do this new one because your exam problem will be harder than this one. Okay. So grab this one and using the transformations, specify domain, range, intercept, and asymptotes. Okay. So remember our parent function x, like that. Yes, hands up, hands up. X squared, x cubed, absolute value, square root, cube root, and exponential function. Like that, right? Shoot. And then logarithmic function. write it down. Okay, so oops. Exponential function going up. It passed through what? 0, 1. Yes, everybody? This is the exponential function. And the logarithm function, remember the mirror image about the line y equals x. So that's why this is ln of x. This is ln of x. Still going up, but curve down a little bit. Okay? So it passed through. What's this point? This point is 1, 0. Okay, everybody? So the key point is 1, 0. Okay, let's start with the parent function. So yeah, this is the parent function, y equals ln of x. It passed through 1, 0, like this. And you want to also write down asymptote. So we have a vertical asymptote, x equal to 0. Okay, so that is the first step. Write down the parent function and write down the vertical asymptote. Remember the order? What's the first thing you check? Shift left or right? And do we have shift left or right? Left. Shift left, 3 units. Yes. So, okay. Y equals ln. Shift left. We add 3 to it, right? So shift left, 3 units. Okay. Left. So 1, 2, 3. What's this point? -2. Yeah, see? -2, 0. Right here. And what happened to the vertical asymptote? See your vertical asymptote here. You shift that 3 units. And now it's at -3. So -3, we have our new vertical asymptote. And then your shape is still the same. Do you agree? The shape is still the same because you shift the whole thing left. The shape is the same. Yes, everybody? Okay. And that's the first step. What's the second step? Reflection over the y-axis. We look at the minus sign in front of the whole thing of the x. The x. Very good. So we have y equals negative sign in front of the x. So this is reflection over the y-axis. Okay, reflection over the y-axis, which means this point flips to the point, what's it? 2, 0. Yeah, this point flips here, 2, 0. Oh, do you see this point? It stays there, right? Mirror image. It stays there, right? So it stays there. And how about the vertical asymptote? It's now at 3. Yeah. Now we can connect those together. Yeah, it's very important to draw the vertical asymptote because you make sure your graph not cross it. You're approaching to it, but you never cross it. Yes, everybody? So far, so good? Everyone? Mm-hmm. Okay, what's the next step? Is that over the x-axis? Very good. And in this case, we look at the minus sign, what? In front of the everything, right? So y equals minus ln of minus x plus 3. This is reflect over the x-axis. Okay, we draw it. Reflect over the x-axis. What happened to this point? Stay the same. What happened to this point? Oh, put it down, right? So 2, 0, stay the same. And that point, flip it down. Okay. How about the vertical asymptote? Stay the same, right? And then, ooh, we connect those points together. Ooh. So our graph going like this. So far, so good, everybody? Okay, what's next? Stretch by a factor of 2. Yes, very good. So we have y equals minus 2, ln of negative x plus 3. So this is vertical stretch by a factor of 2. All right. So what happened to this point? It stays the same because your y coordinate is 0. 0 times 2 is 0. Yes, everybody? So this point stay the same. How about this point? It multiplied by factor 2, right? So it goes down here. So, by the way, we don't know what exactly this point is. We just do an estimate. But at least on the picture, you should show me it's roughly stretched by a factor of 2. Okay, so this point goes here. So it's like here, right? What happened to the asymptote? Stay the same. Okay, now we connect those together. This is what it looks like. See the picture? We stretch by a factor of 2. And at the end, what do? Move up or down, and what we're doing? Move down 4 units. Very good. So minus 2 ln negative x plus 3. Move down, so shift down 4 units. Okay, shift down. So, yeah. This point, we shift down 4 units is at what? Yeah, this is 2, negative 4. So, 2, 1, 2, 3, 4, negative 4 here. Okay, and then here, this point, you roughly shift down 4 units. Okay, so you roughly shift down 4 units, let's say kind of like here. What happened to your asymptote? Stay the same, right? Stay the same. Now we connect those points together. So something like this. So far, so good, everybody? Okay, what do you say the domain? Negative infinity to 3. Do we include a 3? No. How about range? Yes, negative infinity to infinity. Good. Do we have horizontal asymptote? No horizontal asymptote. Do we have vertical asymptote? Yes, at x equals to 3. Yes. So you answer like that. Okay. So exact problem is similar to this. So far, so good. I won't ask you to find the x-intercept or y-intercept because that's harder. Yeah. But domain, range, vertical asymptote, horizontal asymptote, you should be able to figure out by the graph. Okay, very good. Awesome. So yeah, for this kind of problems, you can like just maybe change this 3 to 5, and maybe delete some of the minus and change this to the S7. You can change the numbers and then you can try the problems. The ideas are quite similar. Okay, everybody? All right, let's keep going. Okay. So one way to solve equations with an unknown in the exponents is to rewrite the equation in the log form. We'll see this later. This is equivalent to
I'm sorry, I didn't quite catch that. Could you please say that again?
Did I say hey Siri? Okay. Oh, maybe we will see this later. So you can see. Okay. Okay, so let's solve the following equations for x. Give exact solutions and decimal approximations. So you get the exact solution, and then you plug in your calculator, you get decimals, right? And please keep 3 decimal places. Oh, what did I do? Okay, let's keep 4. So keep 4 decimal places. Okay, decimal places. Okay, let's keep 4 decimal places. Okay, so e to the 2x plus 1 equals 30. So e, how do you get rid of the e? Okay, first of all, do you see this is an exponential term? And it's already isolated, right? The exponential term is by itself on one side. Yeah? So it's already isolated. So we can, how do you get rid of the e? ln. So apply ln on both sides. Okay, so make sure the exponential term is isolated. Okay, then we can apply ln on both sides. What happened to your left hand side? ln and e cancel, right? How do you solve for x? Yeah, subtract 1. So we have 2x. Okay, right hand side. Is this equals to ln of 29? No, we cannot do that. This is ln of 30, subtract 1. And we cannot subtract the 30 and 1. Okay, be careful. This is not ln of 29. It's ln of 30. And then subtract 1. So far, so good, everybody? Yes? What's x? Yeah, divided by 2. So this is the exact solution. Now, put this in your calculator. What do you get? 1.2005. What's the next? 6, right. If the next digit is greater or equal to 5, you round up. If the next digit is less than 5, so less than or equal to 4, you just round up. So far, so good, everybody? So if you have an equation involving exponential term, we first isolate the exponential term, and then we can apply ln on both sides to get rid of the exponential term. Okay? All right, part B. We don't. What do we do first? Is it isolated? The exponential term? No. So we must isolate it first. So what do we do? Add 2. Okay. Yeah, add 2. Then we have 3 times 10 to the 2x minus 4 equals, what is your right hand side? Huh? 12, right? And then what do we do? Divided by 3. Okay, left hand side, we get 10 to the 2x minus 4. What is your right hand side? 4, yes. Okay. What do we do next? How do you get rid of the 10? We apply log base 10. Yes, exponential function and natural log, they are inverse function. 10 to the x and log base 10 are inverse function. So we both sides apply log instead of ln. Okay, log is base 10. So log 10 2x minus 4 equals log 4. Is that okay, everybody? Yes. So log and 10, now they are inverse function. So we can cancel. We get 2x minus 4 equals log 4. How do you solve for x? Add 4. Yes. Log, is it log of 8? No. It's log of 4 and then add 4. Okay. And then we divide it by 2, right? X is log log of 4 plus 4 divided by 2. Questions? Can we cancel this 2 and this 4 and say this is 2? We cannot do that. Can we cancel this 4 and this 2 and say this is 2? We cannot do this. Yeah, so leave it like that. This is the exact answer. Plug this in your calculator. What do you get? So everybody please practice how to put this in your calculator. Yeah. Sometimes you might think, oh, this is so easy, but it's very easy to make small errors like the parentheses. If you put the parentheses in the wrong spot, then you won't get it right. Be careful. That's why I hope everyone try to put this in your calculator. If you have so 2.3010. Do you get 2.3010? Yes, good. Okay, so this is how to solve equations involving exponential function. Do you have questions? Oh, because the parentheses is wrong. So this parentheses goes here. It's not 4. Close it. And then add another 4. Yeah, parentheses, very important. Be careful of parentheses. Okay, good. Yes. That's why I hope all of you can try to practice put this in your calculator. Make sure you know those tricky parts where the parentheses goes. Right. Okay, so those two problems. We have base E, then we can apply ln. We have the base 10, then we can apply log. So you see your calculator? It only has ln and log. It does not have other base, right? Okay, so what happens if we use the same approach to solve this? Well, this is base 2, right? So we want to apply log 2 to x log 2 on both sides. Then now we can cancel the 2. We get x equals log 2 7. But the question is, how do we compute that? So that's why we need next class. We learn about the log properties. Then we will be able to relate this to change base formula. Okay, so next class we will learn the change base formula. So this will equal to, if we change to another base, it's ln of 7 and ln of 2. So this 2 goes in the denominator. The 7 goes on the numerator. Now ln of 7 and ln of 2, we can compute that in our calculator. So this one we can calculate. Yeah, so next class we'll talk about more about this. Now, please practice. Okay, so practice these problems. Good. Great to have some time to practice. It's your turn to do these problems. Oh, by the way, if you have to submit your practice exam or exam correction and record, please submit those on Blackboard. If you see the score is not 10 points, I write a note next to it. Maybe you missed something. So look at the note and see what you missed, and then we submit to gain those points back. Okay? Yes, this is so you want to extract the inside number, the base to the sum. One number is you extract from the sum number to same base as the and then you can handle that. The other number is and then divide it with the exponent. You will have base to the x exponent which means 3 to the x, not 3 times x. 3 to the x equal to 3 to the rule of that is 9 to 3 is 3 times 3 is 3 to the x equals the key rule of 81. Yes. And what's 9? 9 is 3 squared, right? Yeah. So this is 3 to the 4th. Because 9 is 3 squared, and this square is 3 to the 4th. That's why this is 3 to the 4 times 1/4. 3, 4 to the 6. Yeah. So oh, yeah, 4 times. Oh, because yeah. Oh, it's because this is 1/3, right? And the 81 is 3 to the 4. So 4 times 1/3 is 4 thirds. Mm-hmm. Yes. We have enough time. Yes. Try those travels. Okay, so 81. So 81 is 9 squared. 9 is 3 squared. So 3 squared is 3 to the 4. So that's why it's 3 to the 4. And the cube root is like 1/3. That's why 3 to the 4. Ah, you see they have the same base, so the exponents must be the same.
I don't know why I don't know where that comes from.
Oh, have a nice long weekend! Don't forget to do your quiz. If you have questions, ask me. Bye.
So it's
Yes.
yeah. And then there's 3 steps. Basically,
2 methods. you can use both. So yeah,
It's right now, 3 to the 4 times and to the power of 1/3.
you this method is
Because the 81 is equal to 3.
Oh,
And you have that
this,
exponential.
you said this equals to epsilon. This is a log term. You want to write down the exponential term. So this is a base. So you put the base to the power of x equals to this number. And then this one here. Yeah, instead of equal to x, so x equals 3 to the x equals to 7. And then what's 81? Do the yeah, and then keyword is like to the 1/3. That's why you can multiply the exponent. Yeah. Now you see we have the same base, then the exponent is separate. Yeah, 4/3. Okay. And then just nice. Uh, 3.5, 3.6, 3.7. Yeah. You're welcome.